Hey, welcome back to Math Mini Lessons. In this video, we're going to look at part 2 of the 8th grade exam. Specifically, we're going to look at the constructed response questions. In our last video, we talked about all multiple choice. Some of them were also on day 2. So here, we're only going to do the open response questions, and there are 3 types. We're going to have 1, 2, and 3-point questions. But not only are we going to go through that, we're also going to show you how we can do these questions on paper, on scrap paper, and how to transfer them over, if you're taking this test in New York, onto the computer site. And in the description of this video, I have a link to the sample page for the site where you can actually use the equation editor and practice putting in your answers and to see what that looks like. All right, so on this part of the test, you have 3 1-point questions, which are just answers. We have 6 2-point questions, which are usually either show your work or explain and the answer. And then we have 1 3-point question. So altogether, this is 10 points. So this video is probably going to be about 60 minutes to 70 minutes, so a little bit over an hour, because I want to really show how to work through those problems. And for you to also expect, you're probably going to be working for about an hour on this test. Some people may go a little faster, some people may need more time, but I want to give you about an average, so expect to spend about an hour on this day. You do get to use your calculator, but I want you to also practice doing the work on paper and then practice putting those answers on the computer, because that's an additional tech barrier. So with that, we're going to jump right into today's video. Let's jump in and give the answer for the first 1-point problem, number 39. And the answer is 47 1/10. So give yourself 1 point if you have that solution. If you have anything else, any number that is not equivalent to 47 1/10, score yourself 0. All right, let's break this one down. Obviously, it's going to be a volume problem. We can see it with a 3D shape. A movie theater sells popcorn in a cone-shaped container, as shown below. What is the volume of the popcorn container? Round, and this is our next part, is to round to the nearest tenth. So it has to be to the nearest tenth. Okay, so we're going to go to our reference sheet, and you're going to use this formula. Volume equals pi, radius squared, and height divided by 3. So now I'm just going to substitute those values. We know the radius is 3, so pi times 3 squared times 5 over 3. And so I have pi times 9. I'm going to put 9 over 1 times 5 over 3. And now give us pi times 45 over 3, which is the same as 15 pi, because 45 divided by 3 is 15. So now that's the only thing I have to enter into our calculator. So I'm using the same scientific calculator you'll get in class. So 15, and you have to actually look for the pi symbol, and it'll be on the left side. 1, 2, 3, 4 down. So there you'll see it, 15 pi. You'll hit enter, and you get this longer number, 4, 7, and I'm going to go 1, 2. So now you just have to round, because it's a 2 in the hundredths place. We're going to round down to 47 1/10. All right, so hit pause and jot this down. Now, because they didn't say leave your answer in terms of pi, you cannot just have 15 pi as an answer. They wanted you to do the entire piece. And besides that, if you forgot to round, unfortunately, that would also cost you the entire point. Let's look at the next 1-point question, number 40. The answer is 18 feet. So give yourself 1 point if you wrote 18. That's pretty much the only answer I can imagine here. I can't imagine someone putting in an expanded form or anything like that. All right, let's break down how we got it. The area of a square-shaped garden is 324 feet. So obviously, we already know that's the garden. Area is 324, and both sides are going to be the same. So we need to figure out what is the square root of 324. Now, instead of just guessing, again, we're just going to use our calculator. You're going to find the square root symbol, so it's in the second row, right above the 7. And you're just going to put 324, and then I'm going to close the parentheses, which is that button right above the 9. Hit enter, and you get 18. So easy peasy. And I'm using the actual calculator that's on the Nextera app, so you can just see exactly which ones you can press and use. Hit pause and jot this down into your notes or make any corrections that are necessary. One of my faves, here we want to find the length of side AB. It's already diagonal, so I know I'm using the Pythagorean theorem to find the length, because I'm going to create a right triangle. So the answer for here is 13 units. Give yourself 1 point if you got 13. If you had anything else, give yourself 0 points. Okay. Now for here, it doesn't matter if you decide to make your triangle this way or if you decide to make it this way. Absolutely doesn't matter which one, because you're going to have the same length and width. I'm just going to do it like this. I know this is my hypothesis. Here are my legs, and I just have to figure out the side length. So on the bottom, from A to, I guess this is now point C, it's 5 units. And B to C goes from -4 to 8, so that's a distance of 12. So I'm just going to put in my formula. A squared plus B squared equals C squared. 5 squared plus 12 squared equals C squared. 25 plus 144 equals C squared. And 25 plus 144 is 169. If you do not know the square root of 169, again, use your calculator. Right above the 7, square root 169, close it up, hit enter, and you get 13. All right, so again, if you didn't have 13, now make sure you're jotting this down into your notes so you can see what method I'm using, and take a look at your calculator. And I would actually even just practice with the one that's on the computer. Again, I'll have the link to the Nextera site in the description so you can find it and practice with it. But in school, you're probably going to have a very similar calculator. If yours looks different, make sure you know how to find the square roots and how to square numbers. You want to make sure you know where also the pi symbol is on your scientific calculator. All right, let's look at question 42, which is a geometry question. And this one I have to show my work. So not only do I get a point for having an answer, I also have a point for showing good mathematical thinking, communication in my work. So that's really what the challenge is here. All right, let's do the reveal first. The answer for this one is 35 degrees. So that's one of the 2 points. Now let's figure out what's happening in this problem. We have a set of parallel lines, P and Q, and they're cut by 2 transversals. So these 2 parallel lines are cut by this line, and they're also cut by this line. And our goal is to figure out what is angle BAC, which I could already see is part of a triangle. Okay, so how can we figure out what this angle is? Well, I notice that this makes a big triangle. And there's some kids who would see this little triangle, and there's some kids that will see a bigger triangle here. Either one will honestly work, and I could actually show you why on both of them. But let's start with the big triangle first. Actually, let me highlight it. And let's do pink. So we've created a nice big triangle, and we have 2 exterior angles. We have 110 and 105. Using those 2 angles, we can figure out the 2 interior angles of this new triangle. So for this side over here, because the 2 together will make 180, I know that 110 plus 70 will make 180. So this interior angle is 70 degrees. Same thing on the other side. If I have 105, 180 minus 105 would give me 75. So now we have two interior angles and we just have to find the third. So I can do 180 minus the sum of those two interior angles will give me that missing angle A. So 180 minus 145 is equal to 35 degrees. So that is one way that you can solve this problem. Now, some kids, because I like to show like some kids can do other things. So another way you could have approached this problem let me erase this part, is some kids may have only wanted to think of this triangle here, triangle ABC. And that's okay. So if you only saw this little triangle here, then you could have used what you already knew about transversals to find the exterior angles. And if this angle here is 110, this angle up here is also 110. And the same thing goes, if this angle here is 105, this angle here is also 105. And now you've created the exact same conditions, where if this is 110, then I know this part here is 70. And if this is 105, then I know right here this is also 75. So you would have had the same angles in the triangle, even though it's smaller. All right, so here's the tricky part now. We have all this information. How do we transfer it over to show our work? The answer part is easy. The measure of angle, you can type angle, ABC, oops, sorry, said it wrong, BAC, that matters, is 35 degrees. All right, so that's all I have to read right there. Here's the tricky part. I need to be able to explain what else I did to find that angle. That's tricky. And I'm going to do this on a computer pretending I don't have a stylus, because I want to be fair, many kids do not have a stylus. So I know some of you can just use that little pencil and draw out all your work. Awesome. This is easy enough to recreate. But for people who do not, how do we explain our thinking in words? And that's going to be the challenge part. So, okay. What are we seeing and what are we knowing? I notice a triangle is created with lines DA. Actually, I'll use this symbol for DA because why not? DA and line FA with lines DA, FA, and line Q. We have two exterior angles on line Q with 110 degrees and 105 degrees. Using these exterior angles, we can find two angles in the triangle. Let's see. How do I explain this first part? Let's see. Using the interior, we can find two of the angles of the triangles. For angle 110, I used its supplementary angle. Angle, we can say that in a better way. Angle 110 is supplementary to angle 70. And I could even put on the side 180 minus 110 equals 70. Angle 105 is supplementary to angle 75. 180 minus 75 equals, I don't know why I did that, sorry. 1 angle minus 105 is equal to 75. With these two angles, 75 and 70, with these two angles of a triangle, we can find angle BAC. 180 minus 70 plus 75 is equal to 35. And done. So again, not the easiest. This one was really challenging for me, so I want to reread this and just make sure that my thinking is pretty clear. So a triangle is created with lines DA, FA, and line Q. We have two exterior angles on line Q with 110 and 105 degrees. 110 degrees and 105 degrees. Using these exterior angles, we can find the two angles of the triangle. Angle 110 is supplementary to angles angle. This is not angle 110. One angle, one exterior angle is equal to 110 degrees. It's supplementary to a 70 degree angle. I think that's more clear. One exterior angle is equal to 110 degrees. It's supplementary to a 70 degree angle. 180 minus 110 is 70. The other exterior angle is equal to 105 degrees. Its supplement is a 75 degree angle. With these two angles of a triangle, 75 and 70, we can find angle BAC. 180 minus parentheses 70 plus 75 is equal to 35. Okay, so there we have it. And again, this was like what was tricky about it. It was really hard to explain without redrawing, and with some of the geometry problems that might be the challenge. So you might have to use some of the vocab words, the proper terminology in order to explain your thinking so that someone else can follow along. All right, now go into your work and look to see how would you score your response. Would you give yourself a 0, 1, or 2? 1 point for a correct answer, 35 degrees, but also judge yourself on the quality of how you showed your work. Did you do it well enough that another person can follow along? If you did, give yourself another point. But if not, and I really push you to be harder on yourself right now, if there's a chance that it wasn't as clear, then be fair and figure out how to fix that answer to make it more clear so you can get the full point. Hit pause and revise your answer. All right, let's look at this other 2-point problem, and here I'm just explaining an answer. So we have an equation, y equals 1.5x, actually do it in yellow, plus 29, and that models the yearly salary. So let me just put this down, 1.5x plus 29. So y is the salary that employees make in a year, in thousands of dollars, and X is the number of years, and here's our slope or our rate of change. Okay, and they're asking us, what does the slope mean in the context of this problem? So what does 1.5 represent? Well, that represents the increase of every single year. So every year they make an additional $1.5 thousand. And I'm going to put an increase, and I know it's an increase because it's a positive number. It's positive 1.5. And I also know 1.5K is also equal to just $1,500. Okay, so now I just need to transfer that over. I'm only going to use the bottom part for the answer, so let's make that one a little bit bigger, and I just have to put that in my explanation. Let's start by restating the question. What does the slope of the line represent in the situation? The slope of the line represents the salary increase for every year. Every year, an employee makes an increase of $1.5 thousand. I'm just gonna put it in there, 1,500 in their salary. All right, and so let's say you're just comparing both. Every year, an employee makes an increase of $1.5 thousand in their salary. Done. So the only thing I might want to add, I guess this is it. I could just put the equation, the slope of the line, y equals 1.5x plus 29. And that's it. The slope of the line, y equals 1.5x 29, represents the salary increase for every year worked. Every year at the company. Every year, I found an employee makes an increase. I'm going to put an additional. An additional $1.5 thousand in their salary. All right, done. That's it. So look at your answer and look to see, did you write down what the 1.5 represents, that's the additional they make, and did you just explain it clearly? If you did, give yourself 2 points. If you kind of did, it's somewhere in that range, give yourself 1. If you are absolutely nowhere close, then you would give yourself a 0. Like if you talked about the 29, you would give yourself a 0 points. Let's look at number 44, another 2-point question. It is another show your work. So I'm going to give the answer, and then we're also going to show our work. Our answer here is 3 feet per second. So it's a rate problem. And let's go through this problem and see how I show my work on paper and how I transfer it onto Nextera. A dog owner collected data to see which of his 2 dogs runs at a greater speed. The graph and table show the relationship between time in seconds and distance for each dog. So that's kind of important. I have speed is equal to, it's pretty much my distance over time. Like how many feet per second. That's what we're looking for. Okay. What is the difference in feet per second? So that's important. I want the difference in feet per second between the 2 dogs. So let's look at dog A. And we already know that we're going to have a constant speed. So I'm going to choose one of the rates. And I want distance over time, and he does 56 feet per 2 seconds. So his speed is 56 divided by 2. 28 feet per second. That's his speed. All right, let's look at dog B. Dog B, I'm just using I can use any points on the line, to be honest. And I have 1 point already given to us here. So I want to use another point that is directly, I want to use one that is very clear and easy to use. So one that looks like it's right on the crosshairs. And this one here seems to work well at 100. But I can use any of these points. So for example, if I wanted to use this one, which is 8 and 200. So dog B, he's doing 200 feet in 8 seconds. So I can use that one, or I could even use the 100 over 4. I kind of like that one better. 100 divided by 4 is 25 feet per second. It still would have given me the same answer, 25 feet per second. All right, so I know dog A, 28 feet per second, and dog B has 25. So I'm just doing 28 minus 25, and I get 3. That's all I did. All right, so that's all my scratch paper. There's lots going on here. I played with different numbers. So how do I express this on my screen with just words? We'll start with the answer. What is the difference in feet per second between the two dogs? The difference in feet per second between the two dogs is 3 feet. I'm sorry, 3 feet per second. Done. All done. That's my answer. Now I have to go into and show how did I find those speeds. So I'm just going to organize it. Let's start with dog A. A rate of, I'll use the first one I use, 56. Let's put feet. Per second. Okay. I don't know why one it looks scripty and one doesn't. I don't know. It just looks like that. Or 22 feet per second. And then I'll just put dog B. I used point for 100. So its rate, but its speed is equal to, I'm going to change the speed. I'm going to use the same 100 feet over 4 seconds, or 25 feet per second. Okay, seems pretty reasonable. And now I just find the difference between them. Difference between dog, oh, I made one mistake here. I put 23 where in my notes I had 28. So let's fix that. 28. And this is why we constantly go and check, because we can make small mistakes even just when copying. Even when I'm not even computing, we can make small mistakes. So dog A, difference between speed of dog A and dog B, 28 feet per second minus 25 feet per second is equal to 3 feet per second. And done. 28. And I'm just going to reread it just to make sure it makes sense. So I showed dog A speed of 26 over 2 feet per second, or 28 feet. Matches my work. Dog B, I used 0.4 on 100, so its speed is equal to 100 feet over 4 seconds, or 25 feet per second. Difference between speed of dog A and dog B 28 minus 25 equals 3, and done. So this is a 2-point question. Give yourself a point if you had 3 feet per second. And you can see why so many kids will probably just put the 3 feet and take that 1 point, and they don't want to go and do the additional work of showing their work. But even here, all I did was organize my thinking. I just showed what I did to find the speed of dog A, and then what I did to find the speed of dog B. And I just put that into writing that someone else could read and make sense. So even though this is harder because I have to type it and it's not on paper, it's not impossible. It just means taking some of my thinking and figuring out how to communicate it in typing. But you could totally get these additional points. I will tell you that many kids last year lost tons of points because they decided to skip showing their work. They thought it was too complicated, it was too overwhelming, and so they opted out, and they really missed out on doing better on the exam and really showing what they knew, because guess what? They knew how to do it, and they were able to do it on paper. So this is just a tech barrier that they had to overcome. All right, hit pause, look at your answer, and score yourself a 0, 1, or 2. And if you need to make a revision to get an additional point in showing your work, go ahead and do so. And again, I highly suggest you practice putting your answers in this equation sampler. And again, the link is in the description. All right, let's look at question 45. And it does show you work. And don't be overwhelmed if just there's some fractions here. It's okay. If you want to, if that overwhelms you, you can automatically just change these to decimals. There are ways around all this. Anyway, let's look at the answer first. It's a rate of change problem. You have to have something equivalent to 75/100, or you could even have 3/4. Either one will work in there, but I think 0.75 makes a lot of sense, but they'll take both of them. All right, so what are we doing for rate of change? We're looking at 2 ordered pairs, 2 points on a line, in a linear function. We want to know the rate of change. So when I think of rate of change, I think of the change in y over the change in x. Some people put this as y2 minus y1 over x2 minus x1. You can, that can totally work if you have it as an equation. And so what you would do is you have your 2 points, and you could think of this as x1 and y1, and your second set of points as x2 and y2. And what most convention people will do is they'll tell you, well, why don't you just substitute, and you're getting 5 1/4 minus 4 1/2 over 3 minus 2. This is a way that could work. Obviously, if the fractions bother you, just change them to decimals. So you can have 5 25/100 minus 4 5/10 over 3 minus 2. That might work a little easier for you, and then you're going to just get the answer 0.75 over 1, or just 0.75. That's fine. If you kept them as fractions, then you would end up getting 3/4 over 1, which is just the same as 3/4 if you subtract it correctly. So either of these ways will work. I do want to give you another possible way, because sometimes the algebraic way can be a little challenging for students. So I wanted to show kind of how I think when I was thinking of change in x, change in y. Here's my x, here's my y. Here's my first point, 2 and 4 1/2. Here's 3 and 5 1/2. So my x changed, it increased by 1. My y changes, it increased by 3/4. And that's all I did, was I just looked, I went from 2 to 3, so I added 1. And how do I get to 4 1/2 to 5 1/4? Well, if I add a half, that's 5, plus another quarter, that's 3/4. And then I just would have represented it like this, 3/4 over 1. But do whatever makes the most sense to you. So I'm giving you different options here, different ways you can approach it, but choose the one that works best for you. So first I'm just going to put in the answer, what is the rate of change to the function? Let's restate it. The rate of change for the function is 0.75. Done. Now I have to kind of explain how I got the rate of change, and use the way that makes the most sense to you. So for example, I probably, because if the one that makes the most sense to me, I will put change in y, and then change in x is equal to, and I'm going to put another fraction here, and now I would just put in the numbers that I had. 5.25 minus 4.50 over 3 minus 2, which is equal to, and then I put another, oops, I hit the wrong button, which is equal to, there we go, 0.75 over 1, or 0.75. Now, that's all I had to write here. You can see it makes a ton of sense. The only thing that some people get, sometimes depending on who's reading the problem, there are some teachers who don't like seeing multiple equal signs. So I'm just give you that option. So I'm just putting change in y over change in x, and then I put a little space there so you can see what I subtracted, and that is equal to 0.75 over 1. Then I put or 0.75. I'm doing that on purpose because I have known some teachers, as I sit in these rooms and I score math work, who will argue, and they have a point, that if I have multiple equal signs, it's not an equation, and therefore it is wrong. It doesn't make sense mathematically, and so they will take away a point. You do not know which teacher is scoring your constructive response. You might have one that will lean in on, yes, technically that is right, but we're kind of losing the forest for the trees here. The kid really knows what they're doing. Why do we want to take away a point when a kid mathematically knows what they're doing? This kid knows that an equation has just two expressions and an equal sign. And so some teachers will say that and just give the point. And others will really argue that, well, what's right is right in math, and that is not an equation, and so they'll take away the point. You don't know who you're going to get. So I'm just saying I would just take that away and just use one equal sign. And if I have something that's equivalent, I'm going to put or this. And just say that as an equivalent answer. So you can choose either one. Now, if you wanted to do all this as a fraction, you can. The challenge is, if I were to type a fraction with a fraction, look at how it looks. So let's say you wanted to do the other way, and you wanted to have on the top part 5 and 1/4. I'm going to have to type this in there, and then I'm going to have to put this on top again. Again, not impossible. So I can do this. If you wanted to express your answer this way, you can, but you'd have to tap it on top as your numerator. So I just wanted you to know that as well, that you can do this if you wanted to, and then say this is equal to, and then you would just have the same fraction again, but here, what is my fractional amount? 3/4 over 1, or 3/4 for 0.75. Which is equivalent to 3.75. All right, and done. So there you have it. Give yourself a point if you have the answer 0.75 or 3/4. Either one is correct, and give yourself a point if you were able to clearly show how you got that answer, that response. Now, again, please practice it on the equation sampler. Do not let the first time you do this be on a computer. Let's not do this for the very first time during the test. You don't want to do this for the first time on a computer during the state test. You have enough stress in front of you. So practice it now. Again, the link is in the description. And practice typing complex fractions like this, or real challenging fractions like this now, before you have to feel like you're pressured on a state exam. We're almost done with our 2-point problems. Here's another one where we're going to show our work and give an answer. And the answer for this one, x is equal to 8. So that's our final answer. So now we need to actually solve for x. So we're going to do this on paper first, because we are not going to do this on the computer first. There's just too many additional things to take our attention away, and that's when we make mistakes. All right, so first we're going to distribute. 1/4 times 3x is 3x over 4 minus 8 over 4 plus 4 is equal to 2x minus 8. So all I did was distribute. And you can see now my brain is kind of primed to just say what I did, not just do it, but to start thinking ahead, I'm going to have to explain what I did anyway. And now I'm going to want to combine like terms. And here I have 2 whole numbers. So 8 over 4 is just 2. 3x over 4 minus 2 plus 4 is equal to 2x minus 8. 3x over 4 is equal to plus 2. Plus 2 is equal to 2x minus 8. And now I just have to decide where do I want the x's? Do I want my x's to go here and I subtract 3/4 and I subtract 3/4 here? Or do I want to subtract 2, but now here I'm going to have to subtract 2x and subtract 2x. I'm going to tell you, I do not want to do 3x over 4x minus 2x. I don't want to do that. I want to do it the other way around. So I want this to go here, and I want this to go here. So let's start there. We're going to move plus 8 on both sides here. And I have 3/4 x plus 10 is equal to 2x. And now I'm going to subtract 3/4 x from both sides. So now I have 10 is equal to, and over here if I have $2 minus 75 cents, I get 1.25 x. And now I divide, last part, I divide both sides by 1.25. And that's where I'll use my calculator. And I get 10, oops, clear that, 10 divided by 1.25 is equal to 8. Alright, so all that to get our one answer, 8. It's a lot. That's okay. So here I'm just going to put the answer is x is equal to 8. I just want the x to be lowercase. Here's a challenge. Now I have to recopy all this into this over here. So instead of getting upset, instead of going, oh my god, this is too much, think of it as just one line at a time. You were able to do it on paper. You can do this one line at a time. It is worth it. Just tell yourself it's worth it. Show what you know. You know how to, obviously you knew what to do to get 8. So get the additional point. Why not double the points here? All right, so we're going to just start off, and I'm just going to just start putting it in. 1/4 times 3x minus 8 plus 4 is equal to 2x minus 4. Okay? We did the first one. And now we're just going to go to the next line, and I distributed. So I got, I'm just going to put it in again. 3/4 x minus 2 plus 4. Now notice I had to decide, I know that's 2. Let's put in that what I really had at first. 8/4 plus 4 is equal to 2x minus 8. And here I'm just going to write distribute. Okay. Now here I'm just going to do the same thing again. I know in this row 3/4 x, and I'm going to assume that they know that I did minus 2 plus 2, so I'm just going to put plus 2 is equal to 2x minus 8. Okay, and I'm going to put combine like terms. And all I did there was negative 2 plus 4 is equal to 2. Okay, that's all I did. Alright, now I go to my next line, and I decided to subtract 8 on both sides. So watch how I'm going to, because I can't, this is really hard to show this way. So what I'm going to do is I'm going to put it in the same sentence. Okay, watch how I make this look. So 3/4 x plus 2 plus 8 is equal to 2x minus 8 plus 8. Alright, so all I did was, I'm doing that to create a zero pair. Okay, and now that I've done that, I'm going to have my new answer, 3/4 x plus 10 is equal to 2x. Okay, and now what do I want it to do? I want it to move that 3/4. And again, I get it. It feels like a lot. 3/4 x minus 3/4 x plus 10 is equal to 2x minus 3/4 x. If this is feeling like a lot, remember, you're just copying. You already did the work. This is just copying, so it's not really thinking work so much, it's just your copying. And a little bit of just changing the perspective. So again, I'm just going to create a zero pair. Alright, and that simplifies to, on this side just have 10 is equal to 1. And what did I have there? I put 1.25. I kind of like that better. Let's do that. Is equal to, I want to show how I got that. Let's see, how can I express this very clearly to someone? Is equal to 1 and 1/4, or 10 is equal to 1.25. I just want them to see how I got that number, x. Okay, and now I'm going to do this, the last part. 10 divided by 1.25 is equal to 1.25x divided by 1.25, and our final answer, 8, is equal to x. Whew, we are done. And we did that one to isolate the variable. So yeah, this is a lot. Here's all our steps. We had our final answer, and we moved this up a little bit so we have it in here so we can just kind of see all our work. So this is this definitely feels like a lot, and I know that you might be saying to yourself, this is a lot for 1 point. Yes, and the people who will go that extra to get that additional 1 point are more than likely the ones that are continuing to push themselves when they're in high school doing a lot of math. Those are the ones that are saying, yes, it's a little bit more work, but there's worth in that, because you do know how to do this work. You do know how to show your thinking. It's just the challenge of putting it on a computer. Don't let that be the thing that stops you. Don't let doing a little bit more effort be the thing that stops you in this, because I will tell you, it will show up in other places. And if you have a lot of goals, like, hey, in basketball, if someone told you putting a little bit more effort will make you better, like, you put in that extra effort into the things you already like. So push yourself also to do it in things that may be a little bit more challenging, like math. It is worth it, and people will notice that effort, and that will set you up for more success later. So let's just make sure, and all I'm doing is I'm looking over my work and I'm seeing did what I write transfer. So I had this as my first line. Yes. Here is my next line. Matches what I did. I'm just checking to make sure I had the same thing. I move to the next line. And, oh, yep, I skipped it down to just having the plus 2 equals 8x. So I had this. And then in my next line, I added the plus 8 to it. And that gave me this. And then I rewrote it adding the minus. So all I did was I put in minus the 3/4. And I got 10 is equal to 1.25. And I explained how I got this. And I showed my last division pieces. So the only thing I could think of that can probably help to make this look even better is when I created the 0 pairs. Actually, no, I was going to put a parentheses around it, and I don't even think I need to do that. Because if I were to put a parentheses around this, it would make it look like I have to distribute again, like I'm multiplying, which is not what I'm doing. And if I only put a parentheses here, then it would look like 8 plus 8. So I'm not going to use parentheses. I don't need it. But my thinking is very clear, and I'm explaining my work, and I have my answer. So what I want you to do again, go and look at your work, give yourself a 0, 1, or 2. If you didn't get 8, but you had most of these steps, it's possible that you get partial credit. That's another reason why you want to show your work, because if you had any error somewhere, it's possible that you will get some partial credit. But if you don't show any of your work and you had the wrong answer, then you are guaranteed to get a 0. So please show your work. Hit pause, show your work, and actually practice doing this on this site. All right, here's our last 2-point question. We have a list of numbers. We just have to say whether or not they are rational or irrational, and just say how we know. So I'm just going to show you the 5 bullet points and tell you rational, irrational. So for the first one, square root 49 is equal to 7. That's rational. It's a whole number. 1.3 repeated. It's a rational number. It's a repeating, non-terminating decimal. Square root of 32. It's not a perfect square, so it's not a rational number. It's not going to give you a whole number. It's not going to give you a repeating decimal. It's not going to give you a terminating. It's going to be a long number that never ends, that with no real pattern. 7 over 2, that's the same as 3.5, so it's rational. It's a terminating decimal. And 1.234, and there's no other symbols here, so it's just a rational terminating decimal. All right, so that's what you're going to put in to here. You literally just have to retype those in. Square root of 49 is rational because it's a perfect square of 7. Yeah, I think we can put that one in, so that one works. Oh wait, because because 49 is a perfect square of 7. Boom, that makes a difference. 49 is a perfect square of 7. Okay, let's do the next one. 1.3 And I'm going to use that nice little symbol, that little line part. Where are you? There you are. Just so I can type it in. Boom. So it is rational because it's a repeating, non-terminating decimal. Done. Next one, square root 32 is irrational because 32 is not a perfect square. Then next one, fraction 7/2 is rational because it's equivalent to 3.5, a terminating decimal. Done. And 1.234 is rational because it is a terminating decimal. Awesome. So that's it. Just moving this up. That's all you needed to do. So in order to get to 2 points, you had to have all 5 of these right, and you had to give the proper explanations. So check in if you had any of these wrong. Like if you had 1 or 2 wrong, it's possible that you could have gotten a point, as long as your reasoning is there as well. If you just wrote rational, irrational, and didn't give a reason, then you'll probably get 1 point, but not all 2. And if you have too many errors and you didn't have any reasoning, then you would have 0 points. My iPad is almost dying, so I need to hurry up to the next question. All right, hit pause and score yourself and make any corrections. We have made it to the very last problem, the last 3-point problem on this 8th grade test. Honestly, thank you for making it this far. Let's finish off strong and let's jump in. I'll show you the answers first, and then I'll show you how we got there. So for this one, we needed to find the unit rate for the price of fabric from each store. So for A, the rate was $3.50, and for B, the rate was $2.75. And then finally, you had to figure out if you bought 9 yards of fabric at both stores A and B, which one would be more, and the difference would be $6.75 if you bought it from store A instead of store B. Alright, so let's jump in because we also have to show our work. So there's a lot that we have to do for these 3 points. So we'll start off with finding the unit rate for store A. And for store A, we have the equation y is equal to 3.5x. That represents the price in dollars for yards at store A. So my rate is right here at 3.5. It's that coefficient. So that is the same as saying if X is the number of yards, I'm paying $3.5 per yard. And we don't talk that way. We say $3.50. So that's how we got that. So that's the work I have for that one. All right, so now I can use the graph to find the rate for store B. And again, I can use any point. And for store B, again, for my rate, I want to look at the price per yards. So I can either use 16.5 yards, $16.50 for 6 yards, or I can use $5.50 for 2 yards. You can use either one. When you do them on your calculator, 16, let's clear our memory, 16.5 divided by 6, we get $2.75. When I do 550 divided by 2, I also get $2.75. So either one works to get that. So you can see I have my work there. I can see how I got my yards for each one because I'm already pre-thinking. I'm priming myself up to get ready to show my work for this. All right, and now my last part, I need to know what the price difference would be. So if I know the yards, $3.5 store A, then I'm going to do $3.50 times 9, And for store B is $2.75 times 9. So let's clear this out. $3.50 times 9 is equal to $31.50. And store B, $2.75 times 9 is equal to $24.75. And now we're just going to subtract them. $31.50 minus $24.75 is equal to $6.75. So bam, that shows my work there. Okay, so now let's put all this in to get, this seems okay compared to that, some of the other problems. This seems good for these 3 points. So we're going to start by answering, and they're probably going to have different lines there to put the different answers in there. So I'm going to put in for the first part, what is the unit rate for the price of the fabric at each store. So store A is equal to $3.50 per yard. Store B is equal to $275 per yard. Okay, so, and I'm doing this because you're probably going to have different boxes for that, and here I just have one because I just have a sample up there. And for my final answer, it's asking me how much more would you pay for 9 yards at store A and store B. You would pay $6.75 more for 9 yards of fabric at store A than store B. Done. Just want to capitalize that. All right, so now I've already answered my question, so we're good here. Now we just have to go into the show your work. So I'm going to organize my thinking. I'm going to show this part first and then this part. Okay, so, and this is both for unit rate per store. Unit rate for price of fabric. Store A, Y is equal to 3.5x. So the unit rate is 3.5 or $3.50 per yard. Done. That one was pretty easy. There really wasn't any math to do. Here's store B. I used a graph, use point, and again, doesn't matter which one. I don't have to do both, but I'm going to use used point. Let's say I used 16.5 on the graph. So the rate is, and I'm going to put it in now as a fraction, and I'm going to put 16.5 over 6 or $2.75 per yard. So, and that one was dollars, so let me just put the little dollar sign. Not letting me put a dollar sign there. Okay. So, per yard. Alright, so that's what we have there. So I did that part, and now I'm going to go to the next part over here. Difference in price. Store A minus store B for 9 yards of fabric. I forgot the little E here. Alright, so let's go to our last little part, and I just did $3.50 times 9, that's store A, minus $2.75 times 9, that's store B, and I get for my price here $31.50 minus $24.75. Again, all I'm doing is copy, which is equal to $6.75. So that's it. The only thing I'm adding in here are just my dollar signs so that we have them. All right, but that's basically it. So I'm just gonna look over all my work, starting with the bottom. What is the unit rate for the price of fabric at each store? Store A is $3.50 per yard, and store B is $2.75 per yard. Done. You would pay $6.75 more for 9 yards of fabric at store A than store B. I've answered both questions. So now let's look at the show your work part. And I'm just going to, again, read my notes to make sure that they make sense. Unit rate for price of fabric. Store A is equal to Y equals 3.5x. So the unit rate is 3.5 or $3.50 per yard. Store B, use 0.6, 16.5 on the graph. So the rate is 16.5 over 6 yards or $2.75 per yard. So notice I don't have to show them all the division. They probably figured out I used a calculator, but they also know I'm not going to randomly guess $2.75. So they know I used the right operation. And so that's the first part. So for the second part, difference in yards of for 9 yards of fabric, store A minus store B. And I did $3.50 times 9 minus $2.75 times 9. And then I actually just worked it out, put in the final answers, and got $6.75. And that is it. So look at your work now and see, did you get all 3 of those answers? If you got all 3 of the answers and showed all the work, you get 3 points. If you got the answers but your work didn't match, or you did the work but you did some type of computational error, if you have some errors, but generally you knew how to solve it, give yourself 2 points. If you had a lot of errors or you used a lot of strategies that didn't work or make sense for this problem, give yourself 1 point. And if you were way off base or you didn't answer at all, give yourself 0 points. But you have finally made it to the end. So now this is what I want you to do. Go back and look at all you did for day 1 and day 2, and I want you to count up how many points you earned. From multiple choice, those are all 1 point, and from all the constructive responses. Hit pause and add them up and come up with a number. Okay, so adding up all your points, you had 38 points for multiple choice, and you had 3, 6, you had 10 constructive response problems, which could have given you another 12, 15, 18 points. So all together, add them up to figure out how many points you would have had. This is out of altogether 56 points. And what you're going to do is you're going to use this chart here to figure out what your score could have been. So if you would have had, let's say, 28 points, then you would have scored, if this was a state test, 2.61 points. So I made this conversion, I made it a little bit harder on purpose, but this will help you. So in order to get a level 3, for example, you needed at least 32 points to be in a level 3. To be the level 4, you needed 50 points, much higher level of points. To reach a level 2, you needed 22 points. So use this to figure out where you would have been. And if you're not satisfied with your score, go back and figure out where there were opportunities to make more points and practice those questions. You can also ask me more questions, like if there were certain videos, you can look at our library, our playlists in 8th grade to find videos to help you with any types of problems that you want more practice in, or just ask questions in the chat. And if you had other strategies you want to share, put them in the comments as well, or even if you just like the video, put it in the comments. I love reading that. If you thought I could have explained something better, give me that feedback as well, and share this video with your friends. Now in terms of studying, these are the types of problems that were on the test. The biggest ones are equations, EEs, and inequalities, as well as geometry. So right there, that could be anywhere from 56 to 80% of the test, 81% of the test could just be these 2 topics. And then another 16 to 25% is functions. And then you get a little bit of number systems, like the rational and irrational numbers, and then a little bit of data and probability. Well, that's it for today. I hope you found this helpful, and good luck on that 8th grade test. And I will see you in high school, Math Marbles. Take care.